Interest in longevity science has grown rapidly and in a field full of bold claims. An important question to address is how should we evaluate these interventions? My name is Anya, and in this presentation, I'll share the framework from a dietitian's perspective to evaluate both well-established and emerging therapies. My goal is to help cut through the noise and empower you to do the same. Here are the topics that I'll go through today. Before we talk about longevity interventions, I want to clarify what the term means and how researchers go about studying it. The term longevity refers to the ability to live beyond the average life expectancy for a given population. Closely related to longevity is the concept of health span, which is the portion of life spent in good health without major chronic disease, disability, or loss of independence. For most people, the goal is not simply to live longer, but to extend the years of life that are mentally and physically healthy, active, and independent. So that's what I'm referring to throughout the presentation when I use the term longevity. And why does this matter? Many of the leading causes of death today, such as cardiovascular disease, diabetes, and neurodegenerative disease, develop gradually over time. Many of the interventions we study in nutrition and medicine influence these underlying biological systems. By affecting these pathways, interventions may alter the onset, progression, and severity of chronic disease. In other words, the goal is not necessarily to eliminate aging, but to delay the development of disease that limit both lifespan and quality of life. By understanding which interventions influence the biological systems involved in aging, we can begin to identify strategies that may help people live longer while maintaining health, function, and independence. So, how do we go about studying it? Studying longevity in humans is challenging because people live for many decades. Researchers often rely on long-term population studies that follow people for 10, 20, 30 years even. One common outcome used in these studies is all-cause mortality, which simply means death from any cause during the study period. You'll often see results reported in percentages, such as 10% lower risk of death. Of course, this doesn't mean someone avoided death altogether. What these numbers represent is the chance of dying during the study period and how it links to the intervention that is being observed for that study. So, for example, imagine researchers follow 100 people for 20 years. If 20 people die in the control group and 18 people die in the other group, that would represent about a 10% lower mortality risk, even though people in both groups eventually die. These types of studies help us understand how lifestyle patterns, nutrition, and pharmacological therapies may influence longevity. With that, let's take a look at how we'll be evaluating the different interventions. Researchers often describe aging using the hallmarks of aging, which include many complex genetic and cellular processes. For the purpose of this talk, I'll focus on 4 broader biological pathways that are especially relevant to nutrition and health interventions. These are not diagnoses, but biological pathways that influence how the body ages. I will use this throughout the presentation to indicate the primary pathway that a particular intervention impacts. So the first one we have is metabolic regulation. This refers to how the body manages nutrients and energy. This includes processes such as insulin signaling, nutrient sensing, and blood sugar regulation. As we age, these systems can become less efficient, leading to metabolic dysfunction. Some example of diseases linked to this pathway are type 2 diabetes, cardiovascular disease, obesity, and non-alcoholic fatty liver disease. The next one I have here is mitochondrial function. Mitochondria are the energy-producing structures inside of our cells. They convert nutrients into usable energy that cells need to function. With aging, mitochondria often become less efficient and may produce more oxidative stress, which can damage cells and tissues. This decline contributes to conditions such as neurodegenerative diseases like Alzheimer's and Parkinson's, age-related fatigue, and reduced physical performance. The third one is inflammation and immune health. Our immune system protects the body by responding to injury, infection, and cellular damage. However, with aging, our immune system can become chronically activated, leading to low-grade inflammation throughout the body. This chronic inflammation is associated with many age-related diseases, including heart disease, arthritis, autoimmune disorders, and many cancers. And finally, we have structural maintenance. The final pathway here involves how tissues maintain structure and repair themselves over time. A clear example is skeletal muscle. Sarcopenia is the loss of muscle and strength. It's the major contributor to loss of mobility, falls, and reduced independence in older adults. Osteoporosis, which is the decreased bone density, is another condition linked to structural decline. These pathways are deeply interconnected. For example, metabolic dysfunction can increase inflammation, and chronic inflammation can worsen metabolic disease. But by separating them here, it helps us understand the main biological systems that longevity interventions could target. In the lower icons here, I want to step through a quick analogy for how to think about these systems in terms of a house. So one way to visualize it is to think about these key functions in perspective of a house. So metabolic regulation is like the food and fuel supply. So this is what's inside the pantry, the refrigerator, and the gas or electricity supply that keeps everything and everyone fueled. Mitochondrial function, it can be represented by the electrical system, powering appliances and lights throughout the house. Inflammation and immune health, that acts like the alarm systems and smoke detectors, designed to activate when something goes wrong, but problematic if they're constantly being triggered. And finally, structural maintenance is the physical upkeep of the house, such as maintaining the roof, walls, foundation. And without regular maintenance, the structure eventually deteriorates. Now let's take a look at how scientific evidence is structured. This is another important layer that I will use to evaluate the various interventions. Not all studies carry the same weight, of course. This hierarchy of evidence ranks the research based on the strength of the data and the conclusions that we can draw from it. So level 1, we have anecdotes and testimonials. These include personal experiences, social media claims, and informal reports. While they can generate hypotheses, they're not reliable scientific evidence. However, we do often see the strength that these claims hold when a message is amplified on social media. Level 2 is mechanistic theory. This research explains the mechanism of how something might work biologically, but it doesn't demonstrate that a given intervention has a desired outcome in humans. Again, this is helpful for propelling the research forward. Level 3, we have animal and in vitro studies. These are non-human animals, to be clear, and often researchers will first explore a biological mechanism in these non-human animals. And as we'll see with an example later, it doesn't always translate. Level 4 are observational human studies. These include cohort, case control, and cross-sectional studies. These can show associations between behaviors and health outcomes, but they cannot prove causation. Observational studies are not a required step to get to randomized controlled trials. Level 5 is RCTs, and these are considered the gold standard for testing cause and effect relationships in humans. Clinical trials typically progress through 3 phases within RCTs. We have phase 1, which focuses on safety, phase 2, which evaluates effectiveness and establishes a therapeutic dose, and phase 3 that confirms efficacy in much larger populations. At this point, after phase 3, FDA approval may be obtained. And finally, we have level 6, meta-analysis and systematic reviews. These combine results from multiple studies to form broader scientific consensus. Professional organizations such as American Heart Association or the Academy of Nutrition and Dietetics often rely on these meta-analyses when forming their guidelines. Okay, so I want to go through a quick example to show how ideas flow through these levels but don't necessarily pan out. Resveratrol is a naturally occurring compound found in grape skin and red wine, peanuts, and other foods. Early studies showed that resveratrol proteins activates proteins called sirtuins, which are involved in cellular stress response. So we have level 2, the mechanism identified. That's the inflammation and immune health pathway that we talked about on the previous slide. These findings led to a lot of excitement about resveratrol as a longevity compound. Next, animal studies showed lifespan expansion in worms and improved survival in obese mice. So that's level 3. However, results in human studies have been much less impressive, and there's no strong evidence that resveratrol extends human lifespan. So this example highlights why understanding the hierarchy of evidence is important, especially when we have the jump from theories and animal studies to evidence in humans. So simply saying I have a study for that is not enough. And the final caveat here is that the human body is a very complex system, and it's not always possible to isolate a single intervention perfectly. For example, someone following a Mediterranean diet may also exercise more or have better access to healthcare. We can't know for sure what led to better outcomes for that individual. Because of this, studies often capture compounding behaviors rather than one factor alone. Study designs also have limitations and may have flaws, which is why we focus on the overall body of evidence, not individual studies in isolation. That is what we can see reflected in the meta-analysis. Okay, with that covered, I want to shift gears and walk you through how I personally think about evaluating longevity interventions. There's a lot of noise in this space right now, and you can find seemingly convincing material on so many topics if you just spend a few minutes online. So what I want to do is take you through the way I approach this. You can think about it a bit like building a toolkit for healthy aging. Some tools have decades of research behind them and are used all the time. Others are newer and still being studied. And some tools may turn out to be helpful eventually, but right now the evidence is pretty thin. As we go through each intervention, I'll mention the primary pathway of aging that it might influence and the level of scientific evidence supporting it. I'm not here to tell you that we should only consider interventions that have been fully proven in randomized controlled trials. Science doesn't always move that quickly, and sometimes early evidence can still be informative, and personal anecdotes may be more powerful than any scientific consensus. But as healthcare professionals, we do need to weigh the strength of the evidence carefully and be transparent when the data is not there. So why does this perspective matter? I believe that if we can identify the interventions that help delay the development of chronic disease, maintain physical function, and preserve cognitive health, we can potentially extend both lifespan and health span. We can be open about what is strongly backed by science and what might be experimental but promising. With that in mind, we can choose the best options for ourselves and our patients. And we'll begin with the interventions that have the strongest evidence, lifestyle interventions. The Mediterranean dietary pattern is one of the most scientifically studied and evidence-backed diets in the world. It has the strongest human evidence for healthy aging. But you don't have to worry about being on the Mediterranean diet. It's just a label. Think of it more as a pattern of eating that emphasizes fruits and vegetables, whole grains, legumes and nuts, healthy fats, and a moderate intake of fish and other protein sources. Research consistently shows that greater adherence to a Mediterranean diet is associated with lower all-cause mortality. Some meta-analyses suggest that each increase in Mediterranean diet adherence score is associated with roughly 10% lower risk of death during the study period. We have a very large body of evidence with meta-analyses and systematic reviews of cohort studies. The primary pathways affected are metabolic regulation along with inflammation and immune health, thanks in part to the diet's emphasis on fiber-rich plant foods, unsaturated fats such as olive oil, and minimally processed ingredients that support healthy blood sugar regulation and reduce chronic inflammation. There is an infographic here for you to get a glimpse of what the Mediterranean dietary pattern is like. Next, we'll talk about protein. Adequate intake is important for maintaining muscle mass and metabolic health. Large cohort studies state that higher intake of plant protein is associated with lower risk of all-cause mortality and cardiovascular events. This systematic review shown here found that for each additional 3% of calories that come from plant protein, there was an association with about 5% lower risk of death. Here's a little infographic from the American Heart Association for a reference of those plant protein sources. The primary pathway affected here is metabolic regulation, likely due in part to the higher fiber content of plant foods, lower saturated fat intake, and favorable effects on cholesterol and cardiometabolic health associated with plant protein sources. Of course, there are also benefits for structural maintenance related to protein intake from any sources when paired with resistance training. So we'll get into that. Resistance training is a critical component of healthy aging. Muscle strengthening activities are associated with about 10 to 17% lower risk of major chronic diseases, including cardiovascular disease and diabetes. Interestingly, the benefit appears to occur with about 30 to 60 minutes per week of resistance training, so it's not a crazy amount of time. Here's another little infographic courtesy of the American Heart Association. The primary pathway affected is structural maintenance through resistance training's role in preserving muscle mass, strength, and physical function with aging. It also greatly impacts metabolic regulation and inflammation as resistance training improves insulin sensitivity and reduces chronic disease risk. The last lifestyle intervention I looked at was aerobic exercise, and it's one of the most consistently supported longevity interventions. Meeting physical activity guidelines, which is just about 150 to 300 minutes per week of moderate activity, has been associated with roughly 30% lower mortality risk compared to inactivity. This can be achieved through something like brisk walking, cycling, swimming, or similar forms of movement, just 30 minutes 5 times a week. The primary pathway here is metabolic regulation, as cardiovascular exercise improves insulin sensitivity, increases glucose uptake by skeletal muscle, and enhances the body's ability to regulate blood sugar and lipid metabolism. Now we'll move on to dietary supplements. Some have strong evidence for specific health outcomes, but most have not been extensively researched specifically for extending lifespan. Supplements should generally be viewed as adjuncts to, not replacements for, a healthy diet and lifestyle. We'll start with creatine, as it's widely studied for its effects on muscle and cognitive function. Observational studies show that creatine supplementation, particularly when combined with resistance training, can improve muscle strength, lean mass, and functional performance, with doses typically around 5 grams per day. The primary pathways are structural maintenance and mitochondrial function, as creatine supports rapid ATP or energy regeneration, helping to preserve muscle mass and strength with age. While creatine may support healthy aging and cognitive function, there's no clear evidence that it reduces mortality risk. Next, omega-3 fatty acids. They have been studied for cardiovascular and anti-inflammatory effects. Some observational studies link higher omega-3 intake with lower mortality risk. However, randomized controlled trials have produced mixed results, so the evidence for direct longevity benefits remain uncertain. Low vitamin D levels are associated with poor health outcomes and higher mortality risk. However, supplementation in individuals who are not deficient in vitamin D has not consistently shown longevity benefits. This suggests that vitamin D may act as a marker of overall health rather than a direct driver of longevity. So we have the studies, and the outcomes don't pan out for vitamin D supplementation specifically as a tool for longevity. Polyphenols include compounds such as resveratrol that we talked about earlier and flavonoids. These are bioactive compounds naturally found in some plants. They act like antioxidants and anti-inflammatory agents in the human body. These compounds influence many biological pathways related to aging, including oxidative stress and inflammation. So we have mechanistic or animal studies here, but direct human longevity evidence is limited. Finally, we come to pharmacology. This is a broad term encompassing different drugs and their interactions in human bodies to help prevent or treat disease. So these drugs were not specifically developed for longevity. Instead, their potential effects arise from reducing major drivers of aging. Starting with rapamycin, it's one of the most promising pharmacologic longevity candidates in animal research. It targets the mTOR pathway, which regulates cellular growth and nutrient sensing. So we have a mechanistic idea of how it could impact longevity. However, evidence in humans remains limited, and the drug is primarily used as an immunosuppressant for organ transplants. Next, metformin is used to treat type 2 diabetes as it improves insulin sensitivity. Randomized controlled trials suggest metformin may reduce risk of several age-related diseases. However, its ability to extend lifespan in healthy humans remains unproven. Next, GLP-1 medications such as semaglutide are widely used for diabetes and obesity treatment today. Large clinical trials show these drugs can reduce cardiovascular events, body weight, and metabolic risk factors. Because cardiovascular disease is the leading cause of death globally, reducing this risk may influence longevity. However, these drugs have not been directly proven to extend lifespan. We just have a mechanistic idea of how they could potentially. Next, NAD is a coenzyme involved in cellular energy metabolism. Clinical evidence that NAD therapies extend human lifespan remain limited, and the results from human studies have been inconsistent. And finally, the hot topic of the day are some select peptides, specifically those that may soon be allowed for compounding in the US. Various peptides are candidates for anti-aging purposes, and I listed them down below. Some of these peptides have specific medical indications, but broad longevity claims remain largely speculative at this point. Depending on the particular peptide, we have many different pathways of aging that it could impact, and the evidence varies as well. The research in humans simply hasn't caught up, but many of these therapies do appear promising. Here's a summary table with all the info I covered, along with a rating for each intervention, taking a dietitian's perspective. When we step back and look at the full evidence base, a clear pattern emerges. The best supported interventions for healthy aging are still lifestyle-based. Some supplements and medications may eventually play a role in longevity science as well, but at this stage, the evidence for most emerging therapies remains limited compared with the foundational impacts of nutrition and lifestyle. I hope you enjoyed this walkthrough of the various longevity interventions and how they all stacked up. Thank you for your time.